explore these very small distances. So now that we're here, let's sort of look at the world of particle physics. And from our point of view, this is kind of like the periodic table chart that you might see, except this is for particle physicists, and we can't handle that many things that you see in a periodic chart, so we only have a handful of these things. And so the fundamental constituents, as we know them now, are the quarks. That's the stuff that appears there in that orange color. I'll come back and say a bit more about these in a second. Then the other sort of matter particles that we have are the ones in green that you see over there. Those are known as leptons. And then on the right-hand side, in this sort of purple color, what you see are carriers of the force. And I'll come back in a second and tell you a little bit about that, what I mean by that. So this table that you see here, you see the labels U and D, C and S, T and B. Those are the names that we give to the quarks. The first ones are kind of prosaic. The U stands for up, the D stands for down. Okay. On the next level that you see to the right of that, you see C and S, that stands for charm and strange. And then finally on the rightmost side of that, you see T and B. And here it depends whether you're sort of a poet or more prosaic. It either is top and bottom, which we usually use, but some people used to call it truth and beauty. So those are the 6 quarks. And then below that, you see another 6 particles, these leptons, of which you see the E stands for electron, which you might be familiar with. Underneath, let me go off to the right there, you see a Greek mu that stands for mu, for a muon. And to the right of that, you see a Greek tau standing for a tau particle. And underneath all of them, you see this nu that stands for a neutrino. And if you've been, I think, here in the other earlier lectures, you've heard about the neutrino physics. And there are 3 types of neutrinos, each associated with those other leptons. So the electron neutrino, muon neutrino, and tau neutrino. And then finally, on the right-hand side, you see the force particles. And these are particles that carry the forces. So the ones that are labeled Z and W, as I'll indicate in a moment, those are responsible for giving rise to the weak force, which is one example of that would be radioactive decay. The other one that you see on the upper right is in that Greek gamma is a photon, and that's just a particle of light you see over here. And beneath that you see G, which stands for gluon, and that's sort of the glue, the particles that hold together the quarks inside that proton. So those force particles, we think of them as particles that are exchanged to give rise to the force. And I wanted to give you just an example of what I mean by that. So let me imagine the following situation. Suppose that you had 2 ice skaters. So imagine you have 2 ice skaters. And one of them, they're both standing still, and one of them's holding a rock. And that's indicated over here by that red circle that I have there. So they're standing still. They're not moving. And now what happens is the one guy with the rock throws it to the other guy. So what happens? Well, when the guy throws it, it recoils. And so he starts to move back. And then eventually the guy catching it also recoils from catching it and moves away. So sort of in my little cartoon over here, he throws the rock like that, and what happens? The 2 guys move away. So by exchanging this rock, you see that it looks like a repulsive force because they moved away by exchanging this particle. So that's what we mean, sort of a cartoon of that, is what we mean by these other particles over here that give rise to the forces. Those are the particles being exchanged in that interaction, giving rise to them. And then you see in the middle there, in the circle, you see a little gray particle which is labeled the Higgs Boson, and that's what we want to talk about a bit more. So if you ask what are we made of, the stuff that you and I are made of, well, we're in that first column. That's called that first generation, made up of up and down quarks, which make up protons and neutrons. You put together the protons and neutrons and you add to it the electron that you see down below there. You've got an atom, you've got molecules, you've got us. Right? So that first column over there is the stuff that ordinary matter is made of. Well, now let me just take a little diversion over here, because I want to tell you a little bit about mass and the weights of these particles, essentially. And in order to do that, I want to use the terms that